operations: addition, subtraction, multiplication, and division. Division doesn't really apply when we're talking about matrices, but there is an analogous concept of matrix inversion, which you should be familiar with. Now, because this course is free, I'm going to assume that you've taken the time to do your best to prepare for this course. That means knowing the basics of Numpy, Matplotlib, Pandas, Scipy, and scikit-learn. Of course, when I say basics, that might be a little ambiguous. What is basic to me may not be basic to you. So let's enumerate and review what you should have learned so that you can make sure you are well equipped to handle this course. For Numpy, I essentially want you to know matrix arithmetic. In deep learning, we work with tensors, which might sound scary, but we actually just mean array, like a regular old programming array. And if you've been paying attention, the name TensorFlow actually includes the word tensor in it, so you know that it's going to come in handy. Tensors, or if you prefer, arrays, can have any number of dimensions. We have special names for one-dimensional tensors and two-dimensional tensors, which we call vectors and matrices respectively. But you should not be afraid if you see a 3D tensor or a 4D tensor. Okay, so what do we mean by arithmetic? That means your basic arithmetic operations: addition, subtraction, multiplication, and division. Division doesn't really apply when we're talking about matrices, but there is an analogous concept of matrix inversion, which you should be familiar with. You should know when addition, subtraction, and multiplication are allowed. For example, you should know that you can't add matrices of different sizes. Multiplication is a key operation, however. You should know that matrix multiplication is really just a dot product in disguise. In fact, whether you're doing a dot product between vectors or matrix multiplication between matrices, these are the same function in Numpy, it's just called dot. Element-wise multiplication is also an important operation in deep learning, so you should know how to do that as well. In terms of Matplotlib, there isn't really anything fancy you need to know how to do. Just know about line charts and scatter plots, since these are what we'll be using 99% of the time. In terms of pandas, also pretty simple. We basically use pandas to load in tabular data. Pandas does some other useful things, but we won't be making full use of its capabilities. Most of the time, it'll just be to load in a CSV file. Next we have Scipy. Now, I don't anticipate really using Scipy at all, however, that could change. Scipy is kind of like a power version of Numpy, so it has more useful statistics functions, more useful optimization functions, more useful linear algebra functions, and so forth. Numpy is more for those lower level operations like adding and multiplying. Finally, we have scikit-learn. Now, the point of knowing about scikit-learn isn't to know about scikit-learn per se. It's to know about the concepts behind using scikit-learn. In other words, you're going to have to learn about the basics of machine learning in order to make proper use of scikit-learn. Again, I reiterate, I teach this for free, so I don't anticipate any problems catching up. So here are the things you want to remember and keep in mind. First are the basics of classification and regression. You want to recall how to think of these as geometry problems rather than magic machine learning voodoo. Second, you want to be familiar with the shape of data. Typically, for a structured data problem, meaning not working with images, sound, or text, but more traditional business type data, we're going to have two objects which we call X and Y. X represents our input samples, and Y represents the corresponding targets. To give you a simple example, suppose we want to predict whether or not a student will pass a math exam. In order to build a model, we've collected a bunch of data points for students who took this math exam in the past. we record several variables, such as how many hours they spent studying and how many hours they spent playing video games. We would treat these as our X matrix. Our Y matrix would be the target or label, which is what we want to predict in the future for future students. So in the future, we could ask a student, hey, how many hours did you study? How many hours did you play video games? And then, from that information alone, we could make a prediction about whether or not they will pass the math exam. Y would be whether or not the student passed or failed, and coded as 0 or 1. In general, we say that the X matrix is of size n by d, where n is the number of samples and d is the number of features. Y is just a one-dimensional array of length n, which you can also think of as a vector. You also want to know the steps we take in general when we are writing a machine learning script to test out a model we've just learned about. This is going to be pretty much the same every time, so if you don't know this, you're going to be extremely confused. The steps are as follows. Number 1, we load in the data. That's just the X and Y we just talked about. We will use Pandas for this when we have simple data sets, or if we have something more complicated, we'll write our own Python code. Number 2, we can optionally split the data into train and test sets depending on what we are doing. Note that sometimes the term test set is used interchangeably with validation set, in which case the true test set would mean something else. Don't get too fussy over this, it is what it is. Number 3, we build a model. Now in Python, we usually use object-oriented programming, which means our model takes the form of a Python object. In PyTorch, we still use object-oriented programming, in fact, probably more so than what you're used to if you've only used scikit-learn. Specifically, PyTorch uses subclassing in order to build models. These models do not work like what you are used to in scikit-learn, but it's similar. Ultimately, you should still recognize the following steps. Number 4, we fit the model. In scikit-learn, this just means calling the fit function on the model and passing in your training data. In deep learning, this is a little more complicated because we have many more options. Since training in deep learning involves an iterative training algorithm known as gradient descent, we typically plot a loss per iteration when we are finished training to confirm that our training process has converged as expected. If it didn't, we have to go back and make changes. And finally, number 5, we evaluate the model. This involves checking the accuracy of our model on both the train and validation sets. At this time, we can also check to see if the model is overfitting or underfitting. And once this is all done, we can make predictions with our model. In PyTorch, this is a little more complicated than in scikit-learn because PyTorch doesn't really work with Numpy arrays. Instead, PyTorch works with torch tensors. So there will be a lot of times where we have to convert back and forth between Numpy array and torch tensor, depending on what we need at the time. This might seem strange at first, but you'll get used to it as you get more practice. This process encapsulates the typical life cycle of a machine learning model. You load in your data, train a model, evaluate it, and then use it to make future predictions.